Hey everybody, what's up? I guess we're starting a few minutes early, which is good because maybe we'll have some time for questions at the end. I'm grateful to be here today in your beautiful city, all the way from Seattle, Washington, to talk to you a little bit about what I've been thinking about and working on with the folks at Qubole over the past few months. But first, I'd like to recall a talk from yesterday from the fellow from Uber who talked about the similarities and differences between the academic world and the business world. And I'm an academic by trade myself. I'm a physicist. And so one of the academic traditions that we love to engage in is last-minute changes to the title of your talk. So I assure you, though, everything is pretty much the same. I just like this one a little bit better. The structure of the talk that I'm about to give today will involve a few things. First, I recount the standard model of the data scientist because I'm a physicist and we have to talk about standard models. Then I'll get into our model deployment setup at Expedia, how we do it, because I think it'll be interesting for at least I've been told that it's interesting, so I like to get into the weeds a little bit with you and kind of give you a use case for migrating our marketplace design setup from our on-premises data center into the cloud using Qubole. And then finally, hijacking our machine learning model deployment technology to do all kinds of other fun things with our data. Great. So, but first, or second, if you like, a little aside. Another of the great academic institutions that we had, at least in the physics department, was, I guess in most physics departments, is after lunch, you enjoy a coffee and witful banter with your friends and colleagues about basically any ideas that are wandering around your mind. In the United States, we like to call this a bunch of BSing. But effectively, a lot of really great papers, some of my favorite work has come out of these sessions. And every Thursday, we're lucky enough to have some solutions architects, whatever, come down from Qubole, and after lunch, I usually go up there with a cup of coffee and expose them, and I'm grateful, thank you for not kicking me out, because I just come crazy ideas, throw it at them. And everything I'm talking about today has come from 2 or 3 of those sessions of me just coming up with ideas, throwing it at them, and the next thing you know, projects get spun up. So that's, I guess, another similarity, if you like, between the two environments. Great, so there's a lot of folks out there today that are looking to sell you some kind of data platform, some kind of means to do your data science. And when they talk about what they're going to offer you, they're first going to say, well, we're going to load in your data from whatever crazy sources you have. Then we're going to probably take that data and help you train some models on it, whatever, standard stuff. And then deployment. And oftentimes people will talk about like a one-click deployment, click it, set it, forget it, don't worry about it. And that's great, but you as a business owner or member or product-oriented type of person know that you have to iterate on this process. So once you finish deploying the model, it's not enough. You start collecting more data, you recycle the process over and over again. And this is kind of the standard mentality of most technology companies, internet companies going on right now, is this notion of test and learn. Right? Good. So I'm not going to be talking about ETLs today because nobody should talk about ETLs. They're boring. Right? They don't make for great talks. I'm not going to be talking about model training today because honestly, any data scientists in the room know it's boring. You don't want to talk about tweaking parameters and kicking a box over and over and over again. This is stuff that no one should see. This is stuff that you don't even do in the office. You do it in the confines of your work or a cafe or something. Anyway, it doesn't make for great talking. But I also want to point out something that I think is kind of glossed over a lot, and that is statistical machine learning is not for every problem in data science. I'll get to that in a minute. So this leaves us with model deployment. What I would like to encourage folks to think is more than just like a one-click, set it and forget it idea. I really want you to think a lot about how your organization uses your model deployment technology, what you're doing with it, because hopefully I can encourage you to think that there's a lot of products that you can build with this technology, both external, customer-facing. In our case, we're a platform, so we also have products that we can build for our suppliers, our hotels, but internal-facing products too, dashboards, analysis, simulation engines, all these kinds of stuff that you can do with the same technology, and probably some of you do. But there's a lot of room for innovation and a lot of fun to be had. Because again, if you're an academic, yeah, it's a fun and great time to come up with useful products, but ultimately we just want to, still enjoy the work that we do. But to sum up this point and to kind of try to drive home the idea is that machine learning is just one way of scoring things. And oftentimes in this world, you have to score things many different ways, 2 ways from Sunday. So abstract your thinking slightly a little bit. Anyway, how do we do model deployment at Expedia? This is kind of a fun project because, a lot of folks will talk about I don't know. There's this really interesting product put out by the data mining group, Fast Scoring. It's a really fun idea where you have basically infinite flexibility. A lot of people are doing the same thing. You Dockerize your different model deployment technologies and kind of infinite flexibility of what kind of models you can use. Because we all know that some of the data scientists love to use scikit-learn, they love to use Python. Some people want to write their own algorithms or augment some code that they found online. But Expedia, we have this issue, right? So it's great to have, well, let me step back. What do we do often with models, with machine learning models at Expedia? We're often sorting things, right? So you go to the website, you want to sort, for example, hotels or rental cars, that sort of thing. And the reason for that is clear. You want to show customers abruptly, especially on a mobile device where you don't have a lot of screen real estate, what they're interested in. Because if you do that, they're more likely to buy because they're more likely to look at the front top of the sort, right? So it's great. You want to have some high-powered machine learning models to present customers with the thing that they want at the top. But at the same time, if that customer is going to come to your website and it doesn't render fast enough, they're gone. They bounce. They don't even look at what you have to sort. So you have a trade-off between speed and flexibility for your data scientists. And so that's something that we take very seriously at Expedia. So the way we've kind of formalized and arranged for speed, one of our organizing principles, if you like, is basically our model deployment setup. It's very classic, right? You set up some request. So in that request, you have a bunch of things you want scored, and in our case, therefore, sorted, and then a bunch of features that you might associate to them, some dynamic features, like, for example, the price of a hotel. And then there may be some other properties of a hotel, their star rating, their historical properties. They might be a little bit more stable of a signal, so you put that in a cache somewhere that we can rapidly grab. Those two things together go into our model deployment setup, and because we're from the Pacific Northwest, we like to call it our fresh hops service, some microservice. And inside, we have abstracted away the notion of a model into it's basically an XML file, or if you like, a predictive modeling markup language PMML file, if you like, that contains all the data of our model. These two things chug into the service, I guess, and out comes the typical response. So, right, a list of sorted, scored items, and that's our typical workflow for at least deployment of models at Expedia. However, I want to make a caveat. So if you've seen anything I've ever talked about before, I used to be a big believer that this latency problem was huge and it was really important. And also, you kind of want to have standard code amongst all of your analysts, all of your data scientists. And so I was a big proponent of PMML. I'm not saying it's bad. It is a little slower than other things. But what I just want to say is I'm sorry. I get it now. You don't have to pick to a friend. I'm a little bit more flexible in my opinions, especially since our team, our engineers, developed some really great tech that was able to essentially replace PMML with, my personal favorite, Scala, Java, whatever code language model that you want to deploy. So this is basically our current setup now. So now we can either write, if you like, you can think of these all as individual classes within one big microservice. You can write your Scala code, whatever. Since we've abstracted the notion of the model away into essentially a Dockerized container, one wonders, well, okay, so this response will go back to the website in terms of sorting things, but what else can we plug this model deployment engine into? So the engineers are implicitly plugging this stuff into kind of a simulation test engine that they're running for us, so that's something that's obvious. But what other parts of the website might use this platform, this kind of internal tool that we've been now are selling as not just a model deployment, machine learning model deployment tool, but it's a general scoring platform, Expedia. So what else can we plug it into? And when you start thinking about what else you might be able to plug it into, you start wondering about what else you can inject. So I've got all this code already set up. I've got this service. Instead of having a request coming down from the domain, coming down from the website, can I take this service and inject my own data to it? Maybe I am personally interested in how my model is performing in Chicago versus Miami versus New York, and I don't really want to deal with the engineers. I don't really want to deal with their microservice. Before I get there, I just want to make sure some sanity checks, that sort of thing. Can I plug in a Spark data frame into this service? And then when you do it with Spark, you can do it with anything, right? So then you start thinking, well, okay, so everything we've got in the cloud right now, sits in Qubole, at least for us, we've extracted away the data source. So now, right, inputs are abstracted and outputs are abstracted, so it's just a generic scoring service. Lots of flexibility. And I get that that might seem vague, and so I'm hopefully give you a couple of examples on what I mean by that and how you might use it. So the main kind of thrust of this example that I have for you is this notion of platform design or marketplace design, something that we take very seriously at Expedia. So I talked a little bit about hotel sort, like we want to sort things, because again, the idea is customers want to buy things from the top, but once you have this sorted list, we know that customers are more likely to click towards the top. So in some sense, we have some value there. We're trading hotels' value as how valuable they are to our customers for this notion of sort position, right? So if hotels behave in such a way that might offend our customers in some particular way, for example, they might relocate, they might throw them out, relocate them to a different place, which is a huge traumatic event. I don't know if that's ever experienced. We want to discourage that kind of event. Or if they're giving us outstanding rates and availability, beating other websites, we want to reward that behavior. And so sort is also a great mechanism, one of a few that we have, to incentivize. In sense, this is our value that we can offer a hotel. So that's just one example. But when you start talking about incentivizing behaviors, right, there's all kinds of legal and ethical concerns you have to worry about. You can't prejudge. So anyone who's familiar with the story of Minority Report, right, pre-crime, there's a huge moral issue there. If you're going to try somebody for murder before they've committed the crime, we have to be careful. We can only process signals that have happened. So formally, this is kind of a game, right? But we still have the same logical demands. We have input signals that come in. We have output scoring that goes out. And we still have the same requirements. We still have latency requirements. We still have reliability, reproducibility. And if you're keeping score, that's the second typo I've had today. Dynamic, et cetera, et cetera, et cetera. So it's basically the same idea, but it's inherently not a machine learning problem. But the question is, can we use our machine learning apparatus to make our lives easier and a little bit more fun with all this tech that we've built out? And the answer is, of course. So I'd like to give you two kind of examples. One is a fun little example about how we hijacked, or I hijacked Spark's Pipeline ML API to do some of this marketplace calculation for us. And another example, and I'll have demos for these at the end, so hopefully I can crush through this really fast and get to them. Hijacking one of our microservices, our Java microservice that I just pulled it down from a machine learning apparatus and used it for something else, for this marketplace stuff. So let's warm up a little bit. Let's talk about the hijacking the pipeline ML. So here's the basic logic. Here's the problem setup. This is a very common problem, and when we interview candidates, or at least when I interview candidates, this is one of the question types that I throw out at people, right? So here's a basic setup. So consider a hotel. It has some status today, and that status today is a score, say some number, and it's based upon what its status was yesterday and some update value. So these are two numbers. It's in principle a nonlinear mapping. It could be crazy. It could be information, it's deterministic, but who knows what the function is. And we would like to compute this value daily for every single hotel in our setup. So, right, every few years, right, category theory rears its head in the back of your mind as that kind of, and you get really excited about functional programming. And so this is like a really great use case for that, right? So we have 500,000 hotels, say, order, and you want to do a bunch of different kinds of stuff with them. You want to score them daily, but maybe you are also interested in backtesting a change to your model, and you want to score monthly. So you have 500,000 hotels over, 30 days worth of input data, and you want to be able, maybe you want to do it on demand. You have all these different use cases for this, and there's a lot, but it's the same basic setup of calculation. Wouldn't it be great if I could just throw one function down and have it do all of my work? I just have to tell it how many days to go, right? That's probably the best way to keep your code simple, clean, et cetera. Anyway, so the functional programming category theory, what notion of a monad. So caution. So I assume that so I was told there'd be technical people in the audience, and I met some technical people. So hopefully this isn't too much for you. But building your own can be kind of treacherous, especially in Spark, because the way that Scala's programming pattern tends to work, right, it tends to create new objects like all the time. So you have this constant iteration of building more and more and more objects, which can take more and more memory up. That sort of thing. So you need to be a little bit careful about what you're doing. But if you sit down and think about it, as we did right at lunch, you're like, oh, yeah, this is already built into the framework of Spark. Someone already actually wrote this already. And in fact, there was a really great talk at Spark Summit West last June, something like that, by Holden and Seth, where they taught you how to hack or go in and modify the two main classes that make up the pipeline ML. And so for this purposes, I'm going to talk a little bit about extending the class of the transformer class, which pretty straightforward, easy thing to do. So for those of experts in the audience who are interested, let me just very briefly talk about a little bit about how this differs from their talk. So I needed an extra input column. So these are the different inputs that we have. So I needed a notion of a status. So input would be that daily update. I needed a notion of a status. And the rest of this is kind of boilerplate to do, to deal with the code, identify, like each time you spit out a new version of the object, it has to have a different number, et cetera, et cetera, et cetera. But that's the basic change. Now I've got two input numbers, right? Right, good. So and this, you're operating on pipeline ML, right? So you're operating on data frames ostensibly. So you need to set up a schema for it. And so I just need to tell what the data frame to expect, what's the inputs, what's the outputs, blah, blah, blah. So again, the big difference here is I have an extra field called status. And I'll demo all this in a notebook if you're interested. The one thing that I didn't put in the object itself is this function, which I'm going to call a status update, which for simplicity for today's talk, let's just keep it nice and linear, right? So it's just a quick multiplication of status by 0.9 plus the input. Very easy. The reason why I want to keep it, so this is a function that kind of tends to change a lot depending on how we want to evolve our system or how we're scoring or so on, so on, so on. This is kind of like, if you like, part of the design of our setup. So it's nice if you can pass this function as an argument into your setup in the first place. But anyway, so here's the money. This is the transform method that you may be familiar with. And the idea is here, you basically are creating a UDF that calls that function. Easy. There's the code. Not bad. Not bad. OK, so I'll get to a little bit of how we use that code to score incrementally all over a bunch of hotels later in the demos if I can slam through this. But I really want to talk about something I'm pretty excited. This is something I'm pretty excited about, and that's hijacking our own scoring microservices to do other sorts of things. So when I first got to Expedia, this new marketplace design initiative was kind of new, and I inherited it because that's what you give new employees, fun projects to work on. And the way it was set up originally, and the way it kind of evolved, was to be a complex web of bash scripts and Hive scripts that were running on our on-premises data centers, coupled with some Python transformers in the middle. And that worked really well for the time being until you start to realize that this is really rigid, very difficult to make changes, very difficult to make structural changes. And yeah, right, so if you need to alter partitions or you need to rewrite the code or you need to extend it in any kind of logical way, this becomes quite challenging. So since we have this big initiative anyway to move everything up into the cloud off our on-premises data center, it's made a lot of sense to just push it into Spark. Spark's really flexible. So together with some great packages that our engineers developed at Expedia for model deployment, this is the migration that we have begun working on. So some advantages of doing it this way is, one, you've abstracted, in some sense, the data source. That's the goal, right? So not only do we have the data that's coming in from our production service, but we can also run simulations, because every time we make a change to our incentive structure, our set of calculations, which at this point is kind of unwieldy, we want to know what happens, and we want to know what happens over a course of time, because, for example, if any math-type people, that little 0.9 plus increment, which is a good proxy for how it kind of works, that takes some time to evolve out, right? Anyway. But we have some batch production that we want to do, so that would be notion of doing the hotels all day. So we want to run some simulation. Maybe we want to do some live deployment in the future, because a lot of the data that we read in is some competitive shopping information, which might be, for example, prices on our website versus prices on someone else's website. So we're getting to a point where we can consume streaming data. So there might be some kind of real-time stuff that we're interested in doing too. So all of this tech, we would love to have the same single code base for. So just if you're going to try this at home, just a couple of words of warning. One, Spark tuning is a different kind of job, so careful. It takes a little bit of practice. I wouldn't call myself an expert at it yet. Two is, and this is true if you've ever tried to connect your kind of enterprise data platform stuff, like for us, Qubole, your notebooks to GitHub, right? You can't connect it to your internal enterprise GitHub, because then you'd be giving them your source code, which is that you don't want to do. Same thing with Maven, Nexus. You can't really. So you have to find out some intelligent way to automate how you're going to set a jar, build a jar, set a jar, port a jar up to S3. But I'll show you a little bit about how we do that. Anyway, so here's all the junk that we've got. We've got a whole bunch of different kind of input signals that all generate their own scores, right? And we want to run this for all these different kinds of use cases. And so basically, I just told about it. We import the jar, we create objects as appropriate, and we slam it into Spark and hit go. Awesome. And finally, like one little point. So the engineers are using this technology to build kind of model simulation frameworks for us. For example, if we have a hotel sort model and we know that we want to test it in New York, Miami, Chicago, all these big cities, London, of course, they want us to automatically have the suite of tests set for us to go, and all we have to do is one-click upload to integrate, one-click upload test, blah, 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 one-click load to put to production. But with all due respect to the engineers, whenever they build something, it's got a UI, it's complicated, it's clunky, and I need control. So being able to do this yourself puts you ahead of the curve, which is nice. Awesome. OK, so take-home stories before the demo include, 1, hang out with your engineering friends. Buy them beers. Let them build awesome stuff, right? So there's this great article. It's old news by now, I know, from Stitch Fix. I forget the fellow's name. Sorry, but he's like, engineers should not write ETLs. Data scientists write your own ETLs. Free the engineers. Let them build awesome stuff. And this is a clear example as to why. And then use their stuff recklessly for anything you can think of. Awesome. Great. So just a few thank yous. So some great people at Expedia, engineering manager Bashkar, and Andy, the genius behind a lot of the code that we've set up. And then some super helpful folks at Qubole, Manesh, and of course Mikhail, who, that's my third typo, sorry Mikhail. Bam, he and I hammered on the code until it finally started working. So I really appreciate his help getting this project off the ground. Anyway, thank you. Time for demos and questions, but first let's do demos. So we're going to switch over to the demo now. All right. So I've shown you some of the code already, but we'll go through it real fast. At this point, if you have questions, just let me hear it. Let's go. So here is kind of the basic dependencies you're getting. So this is for about awesome. So this perfect timing. Goodness. Can you see my cursor? Yes. Good. So these are the libraries that you're going to need for modifying. This is modifying the pipeline ML transformer class. So these are the different libraries you're going to need. This is some miscellaneous stuff that you typically need with Spark. Right, and then this is, of course, some Spark context-specific items. And here's our famous status update function, which, as advertised, is external. So I kind of simplified, just to make sure the demo would work, this code a little bit. But this class is called Badness. That is its real name, I promise. Don't ask me why. Here's the code that we just previously talked about. So let me run the import. Let me run. Why are you not running? Disconnected. 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 Aha! Right. What's the moral of the story? The fact that it's not working is the fact that it's live demo. Oh my gosh. Okay, at least we have internet. Okay. So while we try to log back in, and while it wants and when it wants, see, look how great our tech is. We're so secure. We have 5 different methods that we need to go to get in. Right, and let me turn my phone off of the airplane mode. Anyway, so are there any questions while I'm trying to figure out how to get this thing off the ground? No. Okay, awesome. Here we are, back to the demonstrations. Hijacking pipeline ML. But I mean, this is pretty straightforward. Has anyone else hijacked any of the transformer logic, any of that kind of stuff in the past for any of your own purposes? It's not bad. It's good fun. So let's hope that the interpreter is still running. Awesome, look at that, it went really quickly, which means I already have my resources pulled in. All my executors or whatever are alive. That's awesome. Great. Status update, boom. Transformer class should already be defined then. Did it go? No, it didn't go. There it goes. All right. Now, here's the problem-specific logic that I'm calling it. So like I said, I kind of simplified things a little bit. So here, I'm just pulling in a couple, like, what is that? A few days of data, you might notice. So ultimately, when I'm passing it, I'm going to load up a data frame that's got input signals, which I'm calling daily badness. So I'm going to load up maybe like ostensibly 10, but it's more like a week's worth of data. And then I'm going to smash it through this monad and hit it, and make it increment daily, daily, daily for every single hotel. Right, so let's run this. And there's the, right there's the thing. So we're basically, for a day and date range, I'm just adding a new pipeline task of badness, and then I'm eventually just going to hit fit, boom, done, right? So let's take a look. Let me run. Come on. Well, I can just fetch the output while it's running. It's going to spit out the exact same thing because I ran this before it started. But so you see here's for a given hotel, for a given set of input badness values, which is, if you like, it's our input signal. Come on, guys. What it's going to do after it finishes running and then re-renders is it's going to spit out a column for every single one. Right, nice and easy. And that's, so these kinds of calculations on Hive used to take us like all day. So this is pretty awesome that I can just get it to run pretty much immediately. So there you go, right? So one data frame, I seeded initial status, and then it just computed bam, 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 all the way down. Cool. That was that. Now here's the money. This is the hard one. This is the one that took a while. This is hijacking our own internal microservices. So just awesome, perfect. Gosh, thank you. So interpreters, I don't know if you're familiar with how Zeppelin works, but Qubole, for example, uses Zeppelin. The idea is that your driver program, your Spark session, or whatever context, is tied to an interpreter for the given notebook. So this is where you set all your parameters and blah, 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 and you do all the tuning. What's fun here is that if you want to add a jar, you just put that jar in S3, hit edit, and you just give it the address. Done. Right? So then you can just import at win. So back to notebook. So here is a bunch of stuff, more things that you need. So this standard Spark stuff, some standard Java stuff. So I'm going to be calling in some Java code, right? But that's why I love Scala. This is part of the reason why I had some trouble believing in Python and Python deployment, is because I broke up with Python a couple years ago, and now I'm a Scala guy, mostly because of this sort of reason. Anyway, here is our Expedia-specific jar. You can see it, you'd call it like just you would in any old package. I need these. Here's a gotcha. Java conversions and Java converters are two different things. You need that, right? And then some date stuff, and then some more stuff, right? So I'm going to run that. Please wait, my notebook is loading. If you didn't see what I did there, I accidentally hit back on my browser. Sorry. The other thing I forgot to do today was get a little dongle, because I use a Mac to plug the Ethernet cable into. God, it's always got to be something, right? Anyway, come on, guys. Are we there? Are we there? Or did we get kicked off of the internet? No, we're still good. Anyway, while this plugs, let me explain a little bit about what it's going to do, right? So basically what I'm doing is I have a calculation. I have a scoring logic, a Scala class sitting wrapped inside some Java code. And that class will basically, I can feed it information about what kind of score I want it to hit. And then, I don't know if you saw that little list that I gave on a slide, so I have all these different kind of signals that we process for this marketplace design initiative. I'm going to hit a score for every single one of those guys. All at once, because instead of having to run a billion bash scripts, I just call one big software component. And then process that for a whole bunch of hotels. I got logged out, and the internet's going really slow. So, in the meantime, any questions about any of this? Anyone tried to do any of this stuff in the past? Oh, we're done. Are we done? Okay. 2 minutes left, but I guess we started 2 minutes early. So anyway, thank you so much for spending your lunchtime with me. I know how important it is. It's my favorite time of day. Please enjoy the rest of your time.